Good evening, my lovely 11th standard warriors. Welcome to the first session of Work, Power and Energy. And we are going to see what work is and what does force do to work. What's the role of force? And how to calculate the work done by the given force. All of this with me. Hello, Crack with Gokulan. Hello, Hema, Saja. Welcome, SD. Welcome, Ankit. Welcome, Anish. Welcome, Rohan. Welcome, Siluia. Welcome aboard. Welcome. This is Shreyas here, your physics master teacher going live at Vedantu. And I have been teaching kids for a very, very long time. I left my job in software a long time ago and I started training kids. And when lots of results, lots of students started doing well, that's when I took up teaching full time. And ever since then, I have never looked back. So glad you are here. And I'm pretty sure you too are going to make it in JEE 2023. You're going to nail it. And we have started our journey with 11th standard in this series called as the Nurture series. So this is a long-term batch for the 11th standard students. So if you have joined in late, go hit the subscribe button so that you do not miss the classes out there. And if you have already hit the subscribe button, if you are already a regular user, you know what to do. Give us that Guru Dakshina by smashing that like button down there right now. Let's get going. Hi Kamlesh, hi Harshil, hello Akash, welcome aboard. And by the way, I have just started up a challenge on Instagram in case you did not notice. Tag me in the memes that are very much relatable to you. Yes, any memes that you can relate to, please go ahead, tag me on my Instagram handle. I'm going to share it. Probably you might get some more followers. All right. So this is a schedule for this week. So all the ones in red is for your 11th standard. So Work, Power, Energy first session, that's today. And the next session on Thursday, that's 16th of September, Work, Energy Theorem and Applications. If you're interested in watching any of the other sessions for 12th standard, you are free to do so. But if you have your seniors, your brothers or your relatives, please recommend the other sessions on this channel. All right. So remember, all the updates do come regularly on our Telegram channel. So check out the link which is there. I'll just show it to you. So when you check out our channel and if you're watching the video right now, all right. So this is me. This was me showing you guys the timetable. All right. And just go below. Well, there is a link for joining the KVPY essay crash course. And that's going on right now. If you want to crack the KVPY exam, it's got tests, notes, it's got live sessions recordings of those live sessions, assignments, everything that you need. Yeah, the pro subscription is also there. Well, yeah, this is where you can check me out on Instagram. This is the Telegram link. So that's how you join the Telegram out there. Cool. And yeah, that's what it is. All right. So we have a lot of students out here. Interesting. I like to see all the chats out here. Very good. Thank you guys very much for all the lovely comments that you give and all the likes, all the warm wishes that you always wish for all of us. Thank you so much, everyone. And looks like Ankit is schooling himself. Oh my God, We Love Football has already joined my Pro Light micro course. That's cool. Welcome. By the way, lots of my micro courses for you guys are there on the Pro subscription. Do check them out. Hello SD Creation. Hello Aditya Narayan. Hello Saja. Welcome aboard. So let's get going. Good evening, everyone. Let's start our session on Work, Power, Energy with a small story. Well, in this story, we have two Pandus. Okay, we have two Pandus. And what are these two Pandus up to? Well, they have an account in a bank. Okay, so that's the bank in which they have an account in. All right. Hello, Hemapriya. Hello, Minakshi. Hello, Dilip. Hello, Ritul. SD Creation is heartbroken. Don't worry, SD Creation, probably I'll mend your heart and dil jodne ka hum kaam karte hain. Yeah, we are going to, make sure that your heart is not broken. You are going to cheer up, bacha. All right. All right. Long time, Chitra. Okay. Now, these two gentlemen, these two Pandus have some money in their account and they can withdraw, they can deposit via a machine, let's say an ATM machine or something. So this Pandu is rich. He has got a lot of money. And this Pandu has a little bit less money. Okay, fine. Now, this Pandu is like, okay, how about doing something for me? Yeah, here is some money. You go do this work. Maybe, I don't know, drive me around or show me the city or I don't know, do something for me. So this Pandu pays that Pandu some money. So, it can happen via physical transaction or it can happen via electronic transfer like a Google Pay, or maybe this guy goes and deposits it in that machine and this guy goes and withdraws it. So once he withdraws, the money gets transferred. You can see that the money goes from this guy's account to that guy's account, all right, via ATM machine, via Google Pay, via Paytm, via physical transfer. It could be anything. Now in the bank, the total money remains constant. In that bank, the total money remains constant. Yes, this account will reduce, that account will increase, the total money remains constant. You need some agent like Google Pay or electronic transfer, NEFT transfer, or an ATM machine or a depositing machine, or a physical person at the bank who can transfer that money from one person to another, or you need to physically go and transfer that money. So you need some kind of an agent to transfer this money. How about this? What if I tell you this bank is nothing but our universe? This is nothing but our universe. These Pandus are nothing but our systems. This cash or this money is nothing but the energy, and this ATM or this agent which is there, that is nothing but the force, and the process of transferring money, or basically process of transferring energy, is nothing but work. So this is the summary of the chapter in a way. Yep. All right. Somebody is asking, what is the meaning of Pandu? Come on, my warriors. You guys are not helping fellow warriors. Somebody is asking, what is the meaning of Pandu? Help them. Poor Pandu says Krutika. Oops. Krutika, help Pandus. Donate some money. All right. So let's get moving, guys. So what has happened is, work is nothing but the process in which energy has been transferred from one Pandu to the other Pandu. Pandus are nothing but system. For example, let's say I have this beautiful pen stand. I got it from Sikkim when I went there a year ago or so. That was before the pandemic hit. And let's say, I lift this up. I'm just going to lift this up. Okay. So what has happened is, I am one system. This pen stand is another system. I transferred my energy. I just ate some vada pav and came, and I transferred my energy to this system. I transferred this energy to this system. So that process is work. I have done some work on this system. But the total amount of energy in this universe is still constant. My vada pav energy went into the potential energy of this pen stand. Everybody agrees with this, I hope. Yes, so I have done some work on this pen stand. Energy got transferred. That agent, who is that agent? Force. Look at this. There is a normal force. So you need an agent. Without that agent, you cannot transfer the energy. I cannot say, Om, Brahm, Brim, Brim, Kum, and okay, energy got transferred. No, it's not going to happen. That's physics. You need some force for the energy to get transferred from one body to the other. So energy is the capacity of doing work. Obviously, work transfers the energy from one body to the other body by the application. That's the agent force. The total amount of energy in this universe remains constant. I hope this is very, very clear. Very good, Vijay. You understood. Kalyani, you are a little bit late. You missed a lovely story of the two Pandus. One was rich, one was very poor bacha. Okay, Theresa, welcome. Biotonians are also here. Welcome aboard. Anish, yes, you are a little bit late, but it's okay. Welcome, Namrata. You're from Tamil Nadu. Welcome aboard. Thank you for all the love from all the parts of the country. Now, how do I exactly define work in physics? Well, obviously you need some force, but that force also needs to displace. Yep, that force also, oops, am I not audible? I hope I'm audible. Yep. Swarlina, join in, you missed a story. Okay. Divyala, I think you have not turned on your speaker. Okay. So, work happens when there is force as well as displacement. But not every force can lead to displacement. Understand that. Only the force which is in the direction of the displacement can create work or does work. So, if something is moving here, I'm applying the force here. In spite of that, if it is moving here, maybe because of some other forces, that force is not contributing in the work. Only those forces in the direction of the work or in the direction of the displacement contribute towards work. So work is the product of the force in the direction of the displacement. The force in the direction of the displacement into how much is my displacement itself, into the displacement itself. Remember, those forces which are perpendicular to the displacement never are responsible for the transfer of energy. Example out here, imagine this. Right now when this box moves from the left side to the right side, obviously gravity or the weight is acting downwards. But that weight is perpendicular to the displacement. It has no role to play. Although force was acting, it did not transfer any energy, it did not change the potential energy of this block. So guys, it has not contributed, rather I would say it has not done work. Yes, the person's force has done work. Also, on the other hand, there would be a normal force. Think about it and tell me guys, will this normal force do work or not do work? Think about it. Does it have any contribution? No, right? So yes, so it will not do any kind of work. This normal force also, because it is perpendicular to the displacement. This is a beautiful example of how, the force is perpendicular. The force is perpendicular to the displacement and it does not do work. This is uniform circular motion. By the way, that's going to be our next chapter. That's a little secret. Okay, so the force is the red one. Displacement is in the direction of velocity. Displacement dx, 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 dx. Every time the force is perpendicular, the kinetic energy is constant. Potential energy constant. It's moving with constant speed. No change in the energy. If there is no change in the energy, no work. Because work is the transfer of energy. It's a process in which energy gets transferred. So if there is no transfer of energy, no work done. So it's not doing any work. So when the force is perpendicular, I hope you got this idea. Now, you might be like, sir, okay, fine, great. A lot of you said no. Excellente. Thank you, Anj Bacha. Will be work affected due to friction? Yes, Nandini. So if some force is being applied and now there is friction, maybe the displacement itself changes. It might become less. So yes, the work might get affected. Yep, it can. Now, let's say I have a force acting on a body, but that force is at an angle with the displacement. And that angle out here is nothing but theta. This force, we all know vector resolution, and you have learned that. Split it into two parts. One force is over here, which is F cos theta, and the other component is nothing but F sin theta. Now you can just forget it. It's like how you forget your ex-boyfriend, ex-crush. Yeah, just forget this force. Yeah. So, is F sin theta, this is F cos theta. Come on, quickly tell me, who is doing work, F cos or F sin? Okay, Saja already said that. F cos theta. Yes, F cos theta. Yes, correcto. So, this is not contributing in the work. So, the work is force in the direction of displacement, which is F cos theta, into the displacement, which is S. But we all have studied something called as the dot product. Force is a vector. Displacement is also a vector. Instead of writing F S cos theta, very good. Everybody said cos, 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 cos. बहुत ही बढ़िया, excelente. Partha, let me just call up, NDA and figure out. Oops. Oh, sorry guys, this was a remote. Oh, sorry, it doesn't work. Oh, sorry, I cannot make calls. Sorry, I'll make a call later on. Okay, and figure out when is the result going to come up. Okay, so coming back, F cos theta into S. So F is force, S is displacement, so it should be F dot of S. This is nothing but your dot or scalar product. Scalar product, because this work, what is this work? This work is nothing but a scalar quantity. This is nothing but a scalar quantity. Very good. Yes, excellent. Yeah, nice phone. Yeah, I can click pictures too. Yeah, smile guys, come on, let me take a picture. Yeah, let me take a picture. Wow, this is like 3 pixels. But I cannot show you. There is no display on this. Okay, I just clicked a picture of you guys. You just can't see it because there is no screen right now. I have to fix it. Yeah, very good. Cool. Chalo. It can do a lot of stuff your phones can't do. And what is a unit? the unit of this work is nothing but 1 Newton into 1 meter is nothing but 1 joule. 1 Newton into 1 meter is 1 joule. Yep, that's all it is, 1 joule. That's the SI unit. Also, you can write it as 1 dyne into 1 centimeter. This is the CGS unit. It is 1 erg. Yes, it is 1 erg. Okay, keep this in mind. So, standard things which you should know. All right. Is double block system easy or not? It is easy if you study under me. Okay, so work is F dot S, which is nothing but F is cos theta, where F is the force, S is the displacement, theta is the angle between the force and the displacement. And the unit of work is joule, and 1 joule, which is the SI unit, is 10 to the power 7 ergs. Ergs is the CGS unit. बहुत ही बढ़िया, excellent है, high संकल्प. Sir, work has direction. Then how it is scalar quantity? Kamlesh bacha, who said work has direction? Wrong. Somebody told you work has direction. Wrong. Force has direction. Displacement has direction. Work does not have direction. Work can happen in some direction by applying force or displacement in some particular thing, but work as such, it has no direction. Okay, it's a scalar quantity. Okay, somebody has told you a wrong information. Oma, welcome back. Okay, now going ahead, there are 3 signs of work. Let me show you why there are 3 signs. Because this quantity can be positive, 0 or negative. When is cos theta positive? By the way, F cannot be positive, negative. S also can't be negative. Force is not negative. This is magnitude. Please understand, this is magnitude of force, magnitude of displacement. So this can be positive, 0 or negative. If this is positive, that means the value of theta is acute. 0, that means theta is 90 degrees. And if it is negative, then it is obtuse. Obtuse. So for obtuse values, it is negative. For acute values, it is positive. For 90 degrees, it is 0. Keep this in mind. Yes. So I have shown that in the next slide out here. For acute values, theta is less than 90, work is positive. Theta is 90, then even though there is force and displacement, work done is 0. We have all seen that. When perpendicular force is applied, then there is no work. And when it is obtuse, the work done is negative. Correcto? Yep. What is the unit called? Ergs. Yes, Gauri Shankar. Ergs is the CGS unit, bacha. CGS unit. 1 dyne into 1 centimeter is 1 erg. Yep. All silver teacup graph. Very good, Saja. Looks like you know it. Oops. Looks like there is one small mistake in the slide. Let me just change it. The answer was there on the slide. So I'm just going to, move the slide around. Oops. Okay, this is like playing games with me. I don't like this, playing games. Come on, please don't play games with me. I don't like it. Okay, looks like the answer was marked. So I'm just going to hide it and just going to magically bring the screen back over here. Okay. Cool. Now we are fine. A body moves a distance of 30 meters along a straight line under the action of 50 Newton. The angle between the force and the displacement vector is 120 degrees. Then the work done is how much? Come on, my warriors. Let's see how many of you can do this. काय झालं अगं बाई काय झालं कुछ नहीं हुआ चलो come on, let's do this. First question coming up on your screen. You have seen the answer, says Krutuga. Oops. Come on guys, still let's pretend we don't know the answer and let's do this. Energy in calories. Yes, energy is also expressed in calories, but that is more in thermodynamics, not in mechanics. Okay, come on my warriors, let's see how many of you can do this question. Let's see if you can do this quickly mathematically. So work is, once again, work is nothing but force dot displacement. So it is F as cos theta. F is 50. S is what is this? S is 30, and this is cos 120 degrees. Now I hope you know cos of 120 degrees is nothing but minus half. That's something which you should be well aware of. Now this 2 and this 30 will get cancelled. Yep, or you can just put this as 25. So this will become 25 into 30 with a minus sign. So that will be minus 750 joules, which is option D. That's the answer. Correcto. Beautiful. Amazing. Let's move on to the next question. Now, what does this negative work actually signify? Now, a lot of people remember it by mathematics, but let me tell you what it actually means. See, when your force and displacement are in the same direction, the work is positive. When the force is opposite to the displacement or obtuse angles, then the work done is negative. What it means is that, think of an example like this. Imagine you call a Superman. You just call him, using this remote, this special remote. You see this red button, you press this red button, you can call the Superman. You call Superman and like, hey, my vehicle just got stuck, my bus is not moving. How about you pushing the bus? So, the moment you press this red button, Superman comes, he comes flying and he pushes. This is the Superman pushing the bus. So, he's doing punya, he's doing a good deed. He's doing a good deed. So, he's doing punya ka kaam. Okay, he's doing a very good thing. So, when you do good work, so force in the direction of displacement, that's positive. You are giving the energy to the system. You are doing a good deed by giving the energy. Superman did a good work. Then you press this, yellow button. You press this yellow button, guys. The moment you press the yellow button, what happens is you can call Spider-Man. So the moment you press this yellow button, and the moment Spider-Man comes, he can, if let's say there is this bus whose brakes have failed or a train whose brakes have failed, Spider-Man will come over here and he will use his webs and he will be like, and he will stop the train. The force which he applies is opposite to the bus or the train's displacement, and that's how he stops it. Now, you might say that, sir, he's also doing good work, but well, let me tell you one thing, guys. He is taking away the energy from the train or the bus. He's sucking it all out. He's taking away the kinetic energy stored in the bus. So, when you take away the energy, you are doing negative work. So, whenever force is opposite to the displacement, keep this in mind that you are taking away the energy, so negative work. And force is in the direction of displacement, you are giving energy, so it's positive. Moving on to the next question coming up on your screen. All right. Yes, thank you, Jitesh. Shreyas Sir, Superman. Okay, let's get moving to the next one. Force of this much Newton acts on a body of mass 5 kg and it displaces the body from this to this. What is the work done? Let us see. How much is the work done? Hello, knowledge facts. You are late, bacha. Okay, come on. Now understood, says Jitesh. So first thing that you need to figure out. What do you need to figure out, guys? You need to figure out displacement. This is initial position. This is final position. You need to find displacement. And what was displacement? Displacement is final position minus initial position. That means 10 I cap minus 2 j cap plus 7 k cap minus initial, which is 6 I cap plus 5 j cap minus 3 k cap. Okay, let's do this. So this will be nothing but displacement. 10I minus 6I, which is 4I cap, minus 2j minus 5j minus 7j cap, 7 minus minus plus, so plus 10 k cap. This is your displacement. Now the last thing, that is work. Work is F vector dot S vector. That means what is the force? It is 10 I cap minus 3 j cap plus 6 k cap dot this displacement, which is 4 I cap minus 7 j cap plus 10 k cap. We all know the simple rule. I goes with I, j goes with j, k goes with k for dot products. So it will be 10 into 4, which is 40, minus 3 into minus 7, which is plus 21, 6 into 10, which is 60. 60 plus 40, 100, 100 plus 21, 121 joules. Let's see how many of you have marked the answer already. No, it is not 150. It is not 150. It is option A, 121. Very good. Knowledge facts, excelente. Very good, very good, very good. Krishna, you're a little bit late, but you can watch the replay later on. You can continue watching it live, or you can slide the slider a little bit behind, catch up at 2x speed, whatever part you have missed. That's how you need to do it. Remember dot product, ax bx plus ay by plus az bz. That's how dot product works. Very good. Cool. Let's get moving to the next question coming up on your screen. Yes, the answer is 121. Oh, what is this dude doing? He is dropping something. Thank you, Saurav. So he's dropping a ball or some mass of 100 gram from a tower and it falls freely. Okay, for 5 seconds. How much work is done by the force of gravity during the time the particle comes down? How much work is done? Interesting. So, what is work? Work is force into displacement into cos theta. In this case, the force is mg. Displacement is the height by which it comes down. Cos theta, well, it is 0 because theta is 0. Why theta is 0? Think, because the weight and the displacement both are in the downward direction. Weight and displacement both are in the same direction. So cos 0, anyways cos 0 we know it is 1. So what is m? M is nothing but 100 gram, which is 0.1 kg. What is g? G is 10 meters per second square. What is height? Oh, that height is not given. Can I find that height out? Yes. How? By this time. How do I use it? Use second kinematic equation. Use this h is ut plus half a t square. So this displacement you can find out. What is u? U is 0. Why? Because it was dropped. So this is 0 plus half into acceleration is 10. What is the time? Time is 5 seconds. So 5 square. So this will become 10 by 2 is 5. So it will become 5 cube. So that means it will become 125 meters. So I should just put over here 125 meters. And now I think I should get the answer. Yep. Yes, so original value is 9.8, but for all practical purposes, Gauri Shankar, if it is not specified, just use it as 10. What's the problem? Just use it. It makes your calculations easy, right? Be happy. 0.1 into 10 gone. So it will be 125 joules, which is option C. Do not mark B. It's negative. It will be positive. Why positive? Force and displacement are in the same direction. Got it? No, it is not B. Be careful. It is not B. It is C. The work will be positive. It's downwards. Weight is downwards, displacement is also downwards, theta is 0 degrees, it's parallel. Okay, all right, let's get moving. Yes, Kamlesh, it is C. Yes, Anup. Yes, Jitesh. Very good, Paulami. Oh, Paulami, it is not 150 joules, bacha. It is the 150 is not even there in the option. Yeah, it is 125. All right, moving on to the next question coming up on your screen. Okay, we cannot use V is equal to U plus AT. Well, knowledge facts, you can use that, but you will get velocity. What's the use of finding velocity? There was no use. We wanted to find displacement. If you find velocity, then again you have to use third kinematic equation, V square is U square plus 2s, and then again solve it. It will be lengthy, so don't use that. It's not needed. Alright, cool. Let's get moving to the next question. Now in this one, there is this mass which is being pulled up by a thread with some acceleration for 2 seconds. What is the work done by tension and tension, gravity and total in that duration? Okay, so first let's mark everything. It is accelerating up with how much? 4 meters per second square. Okay, so now there will be multiple forces. One will be tension, another one will be weight, which is 5g. Okay, so this is nothing but your weight, and by Newton's law, okay, by Newton's second law, one can easily say tension is more, weight is less. That's why this is creating an unbalance upwards and it is accelerating also upwards. So I can say tension minus the weight, okay, is equal to mass into acceleration, which is nothing but 4. Well, you might be asking, sir, why the hell are you using Newton's laws? Can't we just do it directly? Well, I don't know the value of tension. To find the work done by tension, I need to know the tension. So I don't know the tension, so yeah, I'm using Newton's laws. I hope that makes sense. So this will be T minus 50 is equal to 5 plus 4, sorry, 5 into 4, that's 20. So therefore, T is equal to 70 Newton. Okay, and weight was 5g. 5g is nothing but 50 Newton. Okay, now I think we can find other things also, like the displacement. I can use S is ut plus half at square. U is 0 because it is at rest and then it is being pulled. Half into acceleration is 4 into the time is 2 seconds, so 2 square. So this is going to be 4 by 2 is 2, 2 cube will be 8 meters. So the displacement is 8 meters. Now let's come to work done. Work done by tension will be tension into displacement into cos 0. Why is cos 0? Because remember, the displacement is happening here. This is the direction of displacement. Angle between tension and displacement is 0. So what is the tension? Tension is 70. What is the displacement? Displacement is 8 into 1. So this will be nothing but 560 joules. That's the work done by tension. See if this is okay, guys. That's the first thing. Next, what is the work done by gravity? The work done by gravity will be gravity's force, which is 50, into displacement, which is 8, into cos. Be careful over here. Be careful over here. Think about it. It will not be 0. Gravitational force is down, displacement is up. 180 degrees. Be careful. 180 degrees. Yep. So it is 180. And what is cos 180? It is minus 1. So this will be nothing but 400, but with a negative sign. Be careful. Be careful. Do you understand why it is 180 degrees? Hi Rohan, good evening. Wonk. Moody, you are a little bit late. Yeah, you are a little bit late. Yes, Guru Prakash. Very good. It is 180. And the last thing over here is basically the total work. The total work will be work done by tension plus work done by gravity, which is 560 plus minus 400, which is nothing but 160 joules. That's the answer. That's how you need to do it. Yes, correcto. Got it, everyone? That's how you solve problems which involve work, Newton's laws, kinematics. 3 chapters together. But it doesn't feel like it is very bulky. It is fine. Please tell what is tension. Kalyani, check out my Newton's laws lecture. I have conducted a beautiful session on FBD. First class of Newton's laws. I have explained what tension is. Tension is the pulling force inside a thread or slender objects. Okay, just check out the first class of Newton's laws. All right, chalo. Let's get moving. 560 minus 400 and plus 160. Tension is the force which is pulling force in a thread. It always acts away. If tension is 0, it becomes slack. Oh, you're EGL. Why did you change your name? Okay, Guru Prakash. Okay, cool. Let's move on to the next question. This is the best question of today. Okay, let's see how many of you can do this. A 50 kg person has walked 1 kilometer. The work done by friction, if the coefficient of friction is 0.4, is how much? I'm just going to give you 1 minute and let's see how many of you can solve this question in under a minute. Yep. All right. Come on, come on. Excellent, this is Gauri Shankar. You have hardly 50 seconds to solve this and I'm pretty sure you can. This is going to be one hell of a question because many of you are going to make a very, very common mistake. So let's see, 35 seconds more. Come on, my warriors. Let's see if you can get this. It's very easy. Think about it. Some of you have started answering. Come on, good evening, good evening. Hari Krishna Priya Vanka, welcome aboard. What do you think is the answer? 15 seconds to go. Looks like students are confused. They are stuck. Okay, Shalini saying 0. Minus 20, 0. Ta-da! Now, let's go back. Little bit. Let's go back and see where was our definition. Work is F as cos theta. F is the force. S is the displacement, not of the body, of the force. Very important line. S is the displacement of the force. Now, let me go back to this problem. Now, observe his motion. Whenever he touches his feet on the ground, there will be friction. But his foot never ever slides. Check this out. This foot is at rest with respect to the ground. So, if at all this friction acts, this will be static friction. The force keeps acting on the leg till he puts his next leg on the top, on the ground, and then he removes this feet. Once he removes the feet, this friction will disappear. Next, the friction will come on the next feet, but that friction will stay there. It won't move. Just like this friction never moved. So, when I defined work, this work was force into displacement of the force into cos theta. What is the displacement of the force? It is 0. The friction itself did not move. The person moves, that's okay, but the force did not move. Force did not move means, where is the force acting? On the foot. Did the foot move when the friction was acting? No, the foot was on it, it did not move. So friction didn't move. Displacement of friction is 0, work done is 0. That's how it is. You might feel that it is going against your intuition, that no sir, friction is evil, it should have done negative work. You are lying. Let me tell you, I'm not lying, and it is the correct fact, and this is how physics works. Never ever think every time by your intuition. Sometimes you have to go against the intuition. That's what formulas will tell you. And here is the logic behind it. Imagine if I picked up this person. I just hold his head and I asked him, do the same thing what you are doing before I lifted you. What was he doing? He was walking. He was walking like this. I lifted him. He will start moving his legs and hands as if he is walking. Tell me one thing. He would have eaten some vada pav. Sometime back he would have eaten some vada pav. Will that vada pav energy get converted into muscular energy? Yes or no? Come on, think about it. Will the vada pav energy? Yes. Think about it. I am not saying friction won't act. Friction will act, Jitesh, but the friction doesn't move. The displacement of the friction is 0. Friction is there. So will the vada pav energy get converted into muscular energy? Yes. Very good. So now if I drop him, if I leave him on the surface, what will happen? He'll start walking. So actually speaking, the vada pav, the food that he eats, is getting converted into muscular energy, but it is not going in the frictional energy. So friction is not sucking away the energy over here. Understand? It's the muscles which are draining that energy from that person. That's how it is. So friction is there, but work done by friction is 0. So understand that. So static friction is present, but work by it, that work is 0, hence 0 is the answer. I hope, Jitesh, that is clear. All right. Very good. Excellent. So this is the logic behind it. You can ask so many of your, do one thing, you might be enrolled in some other coaching as well. Just do one thing, just ask your friends, just this simple question. What is the work done by friction when he is moving? I am telling you, most of the people will tell negative, because friction is here, displacement is there. And they'll be shocked to know the answer that it is 0. Then be like, what? It's 0? Oh, you mean friction is not there? Trust me on that. Okay, chalo, let's get moving to the next one. 0 is the answer. Now, let's talk about the work done by the variable force. Okay, work done by variable force. Yes, Zayed, your messages are visible, bacha. Anup says clear, Aniket also clear, motivator Kritika, everyone clear, Shalini also understood. Excellent. You think I ate vada pav today? No, actually I ate some biscuits. I am craving for vada pav for some reason. Looks like I'll have to eat vada pav tomorrow. Chalo, let's get going. Will the crash course be available for JEE 2022 after class 12th March April boards? No. It will be a new crash course, bacha. Okay, Srivarshini, it will be a new crash course which will start then. But don't wait for the crash course. Guys, a lot of you I know are thinking, let's do one thing, let's finish this course here on YouTube and then let's join the crash course. Guys, that's the worst mistake you can do right now, because you have time. Crash course is for all the late, arrivals. Students who wake up very late. Like, oh my God, 12 months are over, 2 years are over. Don't do that. Okay, so start attending the regular batches. There are condensed batches which are not crash courses, but it is not a full-fledged batch because already the time has been lost. There are batches which are starting this September. Go ahead, check out the link in the description box. You can study under me and teachers like me in the courses out there. Okay, now what is the work done by variable force? See, till now, whenever the force was being applied, that force was constant. And we said work is force into displacement. But what if when I apply the force itself changes or the direction changes? That is a variable force. And then the work done by such a force needs to be calculated by a special technique. Example, say for example a spring. When I move a block, the spring force will change as the block moves. Everybody remembers work done by, force of a spring? It is Kx. So as x changes, force changes. So the calculation of work will involve dividing the process of the motion into small steps. Divide it into small steps. Guru Prakash is asking what is vada pav? Vada pav is burger, okay? McDonald's burger, Indian version. It is vada pav. Alright. So have vada pav. Guru Prakash, I'm pretty sure you'll enjoy it. This is the best example of this. This block moves, delta x, small displacement, force is F1. Further displacement, delta x2, new force. New displacement, new force. New displacement, new force. Every time the force is different for different displacements. So you need to calculate work done in this and add them up. F delta x1, F delta x2, F delta x3, add them up. Don't you see what is this exactly? What is this exactly? Hello Ankita, welcome aboard. Yes Saja, this is integration bacha. Yep Anoop, nothing is enough Anoop for JEE. You need to practice more bacha. If my videos were enough, they are required. It's necessary but not sufficient. You need to put in your self-effort. If you just watch videos, nothing will happen. Okay, so this is nothing but integration, dividing the entire displacement into small parts. So that's what work is. If you move the body by small displacement ds, in that small displacement the work, this is the work done for a small displacement, then that dw is f dot ds. ds is the small displacement. Okay, you can see that over here. So the total work, so now this is the total work, is nothing but addition, summation, integration. Remember, this symbol is nothing but integration, which is nothing but summation. It's adding all those things. So integral dw, which is dw is nothing but fds. Just substitute it over here. It is integral fds. So everybody remembers integration. So you just need to integrate force with respect to displacement. So Srivarchini, the crash course will start now and it will end after your JEE. So till the last examination. Okay, great. Why not big displacement? Asked Suchi Mama. See, imagine if I have a force which is continuously changing, then every time the force changes, for what duration is the force constant? The force will be constant for a very small displacement, dx. And then for the next displacement, the force will change. For next displacement, the force will change. Again, it will change. So that's why the displacement is chosen dx or ds. I hope that makes sense. If only direction changes, is it variable force? Yes, Rishabh. Even if the direction changes, magnitude remains constant, force is variable. Remember, force is made up of two things, magnitude as well as direction. Any one changes, force will change. Even if direction changes, force will change. So it's a vector quantity. Remember, it's a vector quantity. So even when the direction changes, you need to account for it as a variable force. Yes, dr is also less displacement. Some books use dx, some books use dr, some books use ds. It's all the same thing. Okay, I hope this is clear. Now, whenever we talk about derivatives, we talk about slopes for graphs. But when we talk about integration, what do we talk about? Come on, let's see how many of you remember it. Whenever we talk about derivatives, we talk about slope of a graph. But when we talk about integration in graphs, what exactly do we talk about? Come on, my warriors. Harita also says clearo. Think, recollect. Everybody, come on, my warriors. Hello, Venkateshwara Rao. Yes, somebody is remembering it now. Area. Who is that? Lakshmi Narsimhan Sundarajan. Correcto. It is area. So, work is the area under the force versus displacement. Look at that. It is integration of force and displacement. So, it is area under force versus displacement. Integration is all about areas. Correct. It is not area under slope. There is no such phrase EGL as area under the slope. It does not make sense. There is no term only like that. What is the meaning of area under slope? It's area under the graph. Slope is different. Area under the graph is different. Area under the slope, there is nothing like that. Okay. And area under the force displacement graph gives you the total work done. But you need to be careful over here. Sometimes the force can go below the graph. It can go below because force can be positive or negative, this way or that way. So it can change the sign. So in that case, remember, if the graph is on the upper side, the work is counted as positive. If it is below, it is considered as negative. So this is the best example for that. Imagine if I calculate this area, it comes out to be, let's say, 25. And if I calculate this area, let's say it comes out to be, I don't know, just 5. Then if I ask you what is the total work done from here to here, the answer will be 25 plus minus 5, which is just 20. So that's the answer. So here the work is positive, here the work is negative. Keep this in mind. Yep. Integral means area under the slope. No, Sandhuran. Who told you that? Integral does not mean area under the slope. Integral means area under graph. Slope is different. Slope is a concept. Slope is this steepness. It's steepness. This is dy by dx. Dy by dx is nothing but slope. Okay, this is nothing but the slope. That's it. So it doesn't make sense. Okay, if somebody has told you it is area under the slope, they have told you a wrong thing. Okay, area under force versus displacement gives you work. Okay, very good. Remember, if I write anything else, let's say P is integral, I don't know, something like S and dt. Okay, it could be any physical quantity, some physical quantity. Then it means if you draw the graph of S versus T, then that area gives you P. So remember this, whenever you see integration, okay, this one over here becomes the height, the dt will come over here on the horizontal line, okay, and that area will give you the integral's value. Yep, I hope this is clear. In the picture it shows slope. No, slope is the steepness EGL. Please watch my lectures. I think your basics are a little bit gone, so you need to brush it up, bacha. I think you've forgotten that. No problem, it happens sometimes. So slope is the steepness, how steep it is. The steepness ka area. There is nothing like steepness ka area. Okay, steepness ka area matlab kya? What is it? Nothing. Graph, this is the graph. This exactly is the graph. So it's wrong, it's illegal to say area under the slope. Doesn't make sense. Okay, area under the slope does not make sense. Okay, cool. Let's solve this question. No EGL, that is wrong. Okay, I'm telling you again and again, what you have learnt is wrong. Okay, please remove it from your head. That's where you will make a mistake. Okay, what is the work done by the force in displacing a particle from 4 to minus 2 meters? Yep. Harsh, what is the meaning of variable force? Hash arts, the meaning of variable force is when the force changes in magnitude or in direction or both. Like for example, this one. Force is a function of x. It changes. As x changes, the force changes. Example, spring force. As x changes, spring force changes. F is kx. So that's how it is. Okay? Clear? Okay. Chalo, let's see how many of you can do this. Basic integration. Come on, my warriors. You should be able to do this question. Figure this out quickly. And yeah, let's try this out. What is the work done by this force? Work, we know, is integral force, which is minus 6x cube dot dx. Now when I write this, and this is clearly mentioned from this point to this point. These become the limits. What are these going to become? These are going to become the limits of integration. These are going to become the limits of integration. The initial point will become the lower limit. The final point will become the upper limit. Keep this in mind. -6 is a constant. Take it outside. So this will become -6 integral x cube dx, and you have 4 over here and you have -2 over here. Okay, now let's do this. So this will be -6. X cube's integral is x raised to 3 plus 1 upon 3 plus 1. What is 3 plus 1? That is 4. And I'll be left with just x raised to 4, and I'll put the lower limit here and the upper limit here. I hope this makes sense, everyone. Next up, -6 by 4 is nothing but -3 by 2. So first put -2. So it will be -2 raised to 4 minus 4 raised to 4. 4 raised to 4. That's what it is. Now this will become -3 by 2, and you will have 2 square 4, 4 square 16. So you will have oops, sorry, it's not minus, because I'm raising it to an even power. So it will just become 16 minus, this will become 4 square 16, and square of that 256. So -256. So this will become -3 by 2 into 16 minus 256 is -240. So this will become 120. 120 into 3, 360. Minus goes. So 360 joules. That's the answer. Is it there? Yes. Option D is correct. No, it is not A. Be careful. It is not A. It is option B. 360 joules. Swalina, be careful. Senduran, be careful. Devansh, you are correct, bacha. Yes, it is 360 joules. I think you made a mistake somewhere. Yep, 240 was not the answer. You forgot that 3 by 2 factor, I think, to multiply it. Yeah, so 240 is also there, but you need to multiply it by 3 by 2. Only then you will get it. Very good, Harshita. Very good, Devansh. Very good, Guru Edits. Excellent, excellent. Okay. Hiranya, there are answers for the homework questions, whichever I give. It takes 1 day for the answers to pop up. Okay, so on the PDF, it will be there. All PDFs have answers, including the solutions. So just check it out. Maybe you missed it, and in case there is some PDF which you do not find answer, write a comment. I will respond to the comment, and I will make sure that it gets edited. Okay, fine, Hiranya. All right, let's get moving to the next question. This is a graphical based question. The graph of force versus displacement is given, and the question is, what is the work done? Hello, Dhruv Nawi, welcome aboard. All right, Suchi Mama understood. Saja also clear. All right, let's see how many of you can do this question. The question asks us to find the work done in the first 4 meters. That means you need to find only this area. I hope you see what this is. Nothing but a trapezium. This is nothing but a trapezium. So just find the area of the trapezium. Come on, we all know the area of a trapezium. So the work done is nothing but area under the force versus displacement graph. This is force versus displacement graph, okay, which is nothing but the area of the trapezium. And what is the formula for the area of a trapezium? It is half into the sum of parallel sides. You should know this, sum of parallel sides multiplied by the height of the trapezium. So it is half into sum of parallel sides. This is 2 and the bottom one is 4. So it will be 2 plus 4 into height. What is the height? It is nothing but 40. So what will this become? 2 plus 4, 6. 6 by 2, 3. So 3 into 40, which is nothing but 120 joules. That's the answer. How many of you got it? Beautiful. Many of you got it. Yes, somebody is saying, can we just add the triangle and rectangle area separately? Yes, you can do that. But it's one step more. Why do you want to do that? Remember the formula for area of a trapezium. It helps a lot. It will avoid one step at least. Okay, so you should know the formula for area of a trapezium, standard formula. Let's get moving. So now you got the idea of how to calculate work by a variable force. You can see the force was variable. All right, the force was variable, and that's how we calculated the work done. Beautiful, amazing. Now let's get moving to the next one. But before that, let me tell you, in case you are facing any doubts, difficulties, have conceptual difficulties, want to know whether this method is wrong or correct, in the link in the description box, there is a link to download the Vedantu app. You can also download it from the Google Store or App Store. There is a tab where you can ask doubts with our doubt experts who sit from morning till night. You just take a picture of your doubt and just you can chat with our doubt experts. You can ask whether this is correct or wrong, and they will respond to you in real time. So that's our doubt solving functionality, which is free of cost for all the pro users in classic and plus versions. So that's something which you should definitely look forward to, because it's not good to actually Google answers on the internet, because most of the sites give wrong answers or conflicting answers, and then you are in a fix as to which answer was correct or wrong. Now let's move on to the next one, which is very interesting. Sir, I got 70. Can I take a drop? Yes, Born to Kill, you should in fact take a drop, because for 70 percentile, I doubt you will not get a good college. So if you want to take a drop, please start it now. The batch has already started in June, but there is a new batch which started this September. You can just join this Monday's batch, start it now, and be very serious about the preparation. Just don't depend on random lectures everywhere. Please be systematic and work for it, bacha, and we are always going to be there for you on this channel as well. Okay, so please start your preparation. There is a batch which has started. Very good. I saw the answers given by everyone. Excellent. Shalini, Dhruv, Anup. Very good, Saja. Very good, Paul. Me. Very good, Harita. Very good, Jaswant. Nice to see you, Jaswant, after a long time. Okay. Now, this person climbs the stair in 5 minutes. This person climbs the stair in 7 minutes. Who did more work? Come on. Devant says A. Gauri Shankar also says A. Who did more work? How much percentile is needed for good college? It depends on what is your definition of good college and good branch. So it all depends. You get a good college for 99.9, 99.5, 99, 98, 97, 95 also. It depends on what you want. You want the best college? There's nothing. What do you mean by best college? You know? So best colleges are IITs. For that, you need to clear JEE Advanced. For NITs, you need to get at least 99 percentile. Yeah. Okay. The answer is same. A lot of you got it wrong. Both of them did the same work. The time is different, but the amount of work will be same. What is different is the work done per unit time. This quantity will be different. Understand that. See, if you go slowly, you might reach after a long time, but you have increased your potential energy by the same amount. Understand, potential energy increases by the same amount, same work done. So there is no difference in the amount of work. One is doing the work faster, one is doing it slowly. So the rate of doing work is different. Like, look at this dude lifting this book. The dude is the same, the book is the same. You can see over here, the time is large. The time is large. The power, which is work per unit time, is less. Over here, you can see the time in which he lifts it is small. The power, the rate at which the work is done is more. So when the time is large for doing that work, you are doing it slowly, the rate of doing work, which is power, is less. But when you do the same work in a small time, it's the denominator which becomes small, the power increases. So power is the quantity which you should be looking forward to. Power is the rate of doing work. I hope this animation, this simulation makes it very, very obvious. So power is the rate of doing work, as simple as that. Is the rate of doing work. It is a scalar quantity. So you can see over here, forget this for now, I'll just show this to you in a bit. So power is rate of doing work. Remember, whenever I use the word rate, rate means derivatives. It should automatically click. Rate is nothing but, derivatives, d by d of something. Here, rate of doing work. How much work I do per unit time. What is work? Work is nothing but force into displacement, correct? Force into displacement, bring it outside. So what will happen, guys? You will get F Why? Because F is, let's say, constant. Bring it outside. F dot ds by dt. Oh, but what is ds by dt? ds by dt is nothing but rate of change of displacement, which is velocity. So that's how work is force dot velocity. I hope this is clear. So work is nothing but the rate at which power is nothing but the rate at which the work is done. Work is F dot ds. That's how we defined work. F, you bring it outside, so it will become F dot ds by dt. ds by dt is velocity. So work is F dot v. How fast you do work. So both formulas are, same. Either you can use this formula or you can use this formula depending on what the question is. I hope this is clear. Rishabh, which part you did not understand, please let me know. It was very simple. How quickly you do work. That's it. Work by unit time. So that's what has been mentioned here. Now remember, the SI unit of power is watt. So 1 watt of power is 1 joule of work done in 1 second. When you do 1 joule of work in 1 second, you have consumed that energy, or you are doing that work at 1 watt. Okay, I hope this is clear. Yes, work is independent of time. It depends what is constant. Knowledge facts, do not by heart this. Work is not independent of time. That is a wrong thing to say, because work is, force into displacement. Displacement can be velocity into time. So saying work is independent of time is a wrong thing. Okay, it depends on what is constant and what is not constant. Be careful. All right. Yes. The formula derivation, that is simple, bacha. This is work. dw is F dot ds. F is a constant. F, you bring it outside. That's it. Rules of derivatives. Rules of derivatives. And ds by dt is velocity. That's it. Okay. That's it. As simple as that. Okay. Chalo. Let's get moving to the next thing. But before that, 1 horsepower. 1 horsepower is 746 watts. This is another unit which you should know. So 1 horsepower is 746 watts. Rishabh, how about this? Why don't you replay the part where I derived the formula? Just replay it. You will get it. It's very easy, bacha. It's very lallu. It's like laddu thing. Okay, just rewind the session little bit. 5 minutes, you will get it. Now there are again same sign conventions: positive power, negative power, and zero power. Positive power means energy is given to the system. That means force and velocity are in the same direction. Negative power means energy is taken from the system. Force is here, velocity is here. That means you are trying to stop it. Remember, this was Superman example. Remember the Superman example, and this is the Spider-Man example. Okay, this is a Spider-Man example. All right. And if it is zero power, no energy is transferred to the system. So this will happen when force and velocity are perpendicular to each other. 90 degrees. Saja, work power energy theorem is next lecture. I hope you have seen the timetable. On the timetable I mentioned work energy theorem is next lecture. So in this situation, this person might be applying some pushing force. This pushing force is giving positive power. The friction below might be opposite in direction. So this friction is giving negative power. It's taking away the energy from the system. There is weight which is acting downwards and it is perpendicular to the displacement, so that work done by the weight will be zero, or the power by the weight will be zero. So you can see the same body has multiple forces acting on it, and each force has a different power which is being given or taken from the system. The push is doing positive, the friction is taking away, so negative. Weight, or even the normal for that matter, will do zero work, or it will deliver zero power. I hope this is clear. Okay, chalo. Let's get moving to the next one. All right, here is the question coming up on your screen right now. Come on, my warriors, think about it. Come on. Think. Do this question, guys. It's very easy. Okay, so what is perpendicular to whom for zero power? Force is perpendicular to velocity. Okay, how to remember of formulas in physics? Any tricks, Rishabh? You have to solve lots and lots of questions. That's the only way. Practice it by applying it to problems. You should not sit and memorize physics formulas like you by heart something, I don't know, like ABCD, or probably the names of capitals of states. No, you should not do that. That is really, really bad. In fact, when you solve problems, try not to look at the formulas which are there in your textbooks. Trust me, you will be able to do it. Okay, what is tau? Tow. Oh, what is tow? So towing is basically pulling something. Like let's say your car breaks down. So you dial up the call center and ask, for a crane or some vehicle to tow your car. So tow means to pull something using some other heavy machinery or something like that. Okay, chalo. Walking on the ground is no work by the friction. Okay, chalo. Let's do this question. If you can get this, it will be very, very interesting. Come on, my warriors. Somebody is saying option D, somebody is saying option C. Okay, well. What you need to do? The force required to tow a car at a constant velocity is directly proportional to the velocity itself. So the force is directly proportional to velocity. Therefore, F is some constant into velocity. I'll just put it like that. Fair enough. Now, it requires 300 watts to tow the car. That means there is some power required. And what is power? Power is force into velocity. But force is kV. So it will be kV into V. Therefore, it will be kV square. In general, what did I get? Power is kV square. Now, this is the interesting part. Observe this. Initially, the velocity was 9. Now, the velocity became 36. How many times did the velocity change? How many times did the velocity change? Dama Sarairam, I have already conducted a lecture in Newton's laws, how to draw free body diagrams. Please watch that lecture in detail. Okay, I have given all the tricks and all the methods to draw the free body diagram. Lecture 1 of Newton's laws. Okay, how many times? It has become 4 times. Do you see that? 9 4s are 36. So that means this velocity became 4 times, but the velocity is squared, so it will become 4 square times. So the power will become 16 times. So when it becomes 16 times, what should be the new value of power? It should be 16 into the original power, which is 300, which is how much? 16 3s are 48. So more 2 zeros. 4800 watts. Yep, that's the answer. Where is 4800? That's option B. Option B. Many of you said C option. Somebody said C option. All of them are wrong. Guys, it is option B. Option B is correct. Okay, be careful. You guys made a mistake. So velocity becomes 4 times, but force itself was dependent on velocity. That's why you got the wrong answer as C. Understand? Force also has increased 4 times. So 4 into 4, 16 times. So hence the answer is 16 into 3, which is 48. Yep. Make sure you guys got it. So the catch over here was many people forget that force itself was dependent on velocity as per the given information. Yes, answer B is correct. Moving on to the next one. Okay, it is an amazing question. Last part is not clear. Suchi Mama, it was simple. See, think about it. If I tell you this is P is equal to some constant into V square, velocity changes 4 times. So V square will change 4 square times. So if power, if you talk about power, power will change how many times? 4 square times, which is 16 times. So 16 times of what? 16 times of 300. What is 16 into 300? 4800. As simple as that. Okay, that's it. All right. Moving on to the next one coming up on your screen. Okay. What happened to K? K does not matter. It is number of times. It's a constant, Agilan. It's times. You have studied these kind of things in 8th standard. This is 8th standard question. You give this question to 8th standard kid also, he will do it. You ask the kid, okay, you don't even tell him what is power. You just tell him some quantity. X is some constant into Y square. Y changes 4 times. Just give it to him. Ask him how many times does X change. He'll be like, obviously this changes 4 times. This will change 16 times. Yeah, this is like 8th standard or 7th standard stuff. You would have done this. Okay. Yeah, it's a constant, bacha. It will not play any role. Let's see if you can get this. A force F acting on a body depends on its displacement S. Force is proportional to S raised to minus 1 by 3. The power by that force will depend on the displacement as. Okay, looks like this will involve derivatives. I'm warning you in advance. Force is proportional to S raised to minus 3. So I can write F is some constant into S to the power minus 1 by 3. Achha. How will the power depend on the displacement? Power is force into velocity. Okay, so think about it. Power is force into velocity, and I don't know how the velocity is changing. Velocity can also depend on the displacement, so I need to be very careful about this. So let's do one thing. How about writing force as mass into acceleration, and this will become k into s raised to minus 1 by 3. I can write acceleration as dv by dt. Achha, so this is dv by dt is equal to k s raised to minus 1 by 3. There is velocity, there is time, there is displacement. Three things. I should never have three variables. I should have only two of them. Use chain rule. Everybody knows this. dv by ds and ds by dt. If you notice, I have multiplied and divided by ds. So anyways, they get cancelled. So this will become k into s raised to minus 1 by 3. But what is ds by dt? ds by dt is nothing but velocity. So therefore, this is m dv by ds into velocity is equal to k s raised to minus 1 by 3. Rate of change of displacement is velocity. Now shuffle these terms, write it in a beautiful form like this. v into dv is equal to, bring the m down, so it will become k by m. Take that ds up, s raised to minus 1 by 3 into ds. The reason why I did it is because I want all the v terms and all the s terms on other sides. Now integrate both sides. Integrate both sides. Here is what we'll get. Let's see what do we get, guys. Come on. So integration of velocity will give me v square by 2. Correct? V square by 2 plus, sorry, not plus, is equal to k by m. This integration, s raised to minus 1 by 3 is s raised to minus 1 by 3 plus 1 is s raised to 2 by 3 by 2 by 3 plus some constant. Well, I can say that when displacement is 0, velocity is 0. Therefore, 0 is equal to 0 plus c. That clearly tells me c is 0. So that's the constant of integration which is turning out to be 0. Now let's do this. V square by 2 is equal to k by m s raised to 2 by 3 by 2 by 3. Doesn't matter. V is nothing but or else v square is nothing but some constant, doesn't matter, some constant. This 2 by 3, 2, k, all these are constants into s raised to 2 by 3. Take roots on both sides. So v will be a new constant into s raised to 1 by 3. That's it. Now my job is done. I'll tell you why. Power is force into velocity. Force was directly proportional to s raised to minus 1 by 3. Minus 1 by 3. Correct? You can see that. Here, velocity is proportional to 1 by 3. This is s raised to minus 1 by 3. This is s raised to 1 by 3. So it will become s raised to 0. So hence option D is correct. Yep, option D is correct. As simple as that. Yes, obviously, Ramesh. How do I think like this? Because of practice. As simple as that. Welcome Asma Fedos. Welcome aboard. Yep. So understand. A lot of people think, can I study work power energy separately? You know, a lot of YouTubers fool you guys. A lot of you do not know that you guys get fooled by a lot of YouTubers. People say that yes, you can study Newton's laws separately, you can study work power energy separately. Even if you have not studied units and dimensions, even if you have not studied integration, kinematics, nothing, you can still study rotation, you can still study SHM. They have just fooled you guys. You cannot study. The order of topics is important. If you have not studied vectors, you cannot study Newton's laws. If you have not studied kinematics, you cannot study the next chapter. If you have not studied relative motion, you cannot study Newton's laws. If you have not studied Newton's laws, you cannot study work. If you have not studied work, you cannot study, momentum conservation. If you have not studied momentum conservation, Newton's laws, etc., you cannot study rotation. If you have not studied rotation, circular motion, you cannot study SHM. If you have not studied SHM, you cannot study waves. If you have not studied waves, you cannot study light waves. If you have not studied light waves and SHM, you cannot study AC. Understand, it's all dependent. Okay, chalo. So what has happened? Force was proportional to s raised to minus 1 by 3. Because I didn't want F, I wrote it MA, A is dV by dt. Because I don't like time, velocity and displacement, I use chain rule. ds and ds, I just multiplied it. But ds by dt is velocity. That's it. And take that ds on the other side, s ds, and here I'll get v dv and integrate. The moment I integrated, I got this expression with some constant. I eliminated that constant by assuming when displacement was 0, velocity was 0. So constant is 0. Okay. And from this I got this expression. 2, m, k, etc. are constants. So I just wrote it as a constant. Take roots on both sides. So I'll get v is some new constant into s raised to 1 by 3. Last step, power is proportional to force and velocity. Force was proportional to minus 1 by 3 displacement's power. And velocity, I just got it proportional to s raised to 1 by 3. Add the powers, it will become s raised to 0. So hence the answer is option D. Yep, that's how it is. I hope this is clear. Joshi Joseph, you know my Instagram handle, that's it. It's there. Now this is your homework question. Let's see how many of you are really quick in posting the homework question out there. It's very important. This is a homework question. I'm just moving out. You can take a screenshot as well. First homework question. Second homework question is this one. Okay, train's velocity and frictional force is given. What is the power of the engine required to move it with that speed? Okay. Now remember, my micro courses are starting. You know, my micro courses are there. Capto's micro courses are there for, so for 11th standard, it's also there, and it's also there for 12th standard. These are my micro courses. Remember, the batches which are there, they are in English and Hindi both. You will also get, you know, parent teacher sessions. You will get guidance session. You will get guidance sessions. You will also get strategy sessions as a part of the long-term course. Also, you will get all the classes will be live plus recorded. Also, other courses like KVPY, etc. are a part of it. Tests, assignments, booklets. Which is that booklet called? That booklet is called as Tattva module, will also be given to you. All of this at a very, very affordable price. But there are 3 packages that you need to choose, either one of them, either light. In light, you get everything I told you. But if you want doubt solving on the mobile app, then you go for the classic version. Okay, after the class, I just showed you what is the doubt app. And if you want a personal mentorship, then you go for the plus version. The batches are starting this Monday and the course price is very, very reasonable. 3,600 rupees per month when you use my coupon code SHHPRO. Remember, by heart this code, you need it to get the 10% off. It's the maximum discount you can get on the pro subscription. Including the my micro courses are free of cost. Can we subscribe only to micro course? No, ma. Yep, that's not. So micro crash courses which are available, remember they are all recorded, but if you want the exclusive micro courses like KVPY micro course, problem solving micro course, they are not available to buy also. They are only available only on the pro platform. You might see some micro courses on the Vedantu platform for 1 rupee or 2 rupee. Those are not those exclusive. These are, you know, those standard courses which are there. The exclusive courses will only come once you enter into the pro subscription, not otherwise. So like my micro course, you will not see it anywhere on the website. Once you are inside the pro subscription only, you will be able to see it. That's how it is. Okay, the next session will be on, I think I just mentioned the timetable, just browse through the Telegram channel. It's there. I think it's on Friday if I'm not wrong. Okay, tomorrow I'll have a 12th standard class, and yeah, every day 7:30. So make sure you check the timetable. I have already posted it on the community page. I hope you guys know how to check the community page as well. It's all there over here, guys. Okay, so when you go to our channel and hit the community, that's it. You will see it over here. You can see, yep, over here daily timetable, and you can see over here daily schedule, and this is my schedule. This is a physics schedule, physics weekly schedule. Yeah, Warriors see you live. That's what I posted. You can see it. So you can see my next class, work kinetic energy theorem and applications for 2023 Thursday. Oh, it's not Friday, it's Thursday, 7:30 p.m. Okay, so that's how you check it out. And also, yep, let me show you over here in this home right now. If you're watching this video, you will, yeah, you can go down, 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 and this is how you can join our Telegram channel. There's a link. This is my Instagram channel link, and you can see the KVPY essay crash course link. Okay, you can join it from there. You can also join the pro subscription from this particular link. This is a long-term 2-year batch. This is a 2-year batch. 2-year batch price is just 54,000 or just 67,500. 2 years price. This is reasonable beyond expectation. Too good to be true. Okay, and it is available for 10% discount when you use my coupon code. Remember, SHHPRO. Good night, take care, have a great time, and post the answers in the comment section of the homework. Do not forget to smash the like button as well. Thank you guys for tuning in. Have a safe night, stay at your home, and be really healthy, and do not go outside without your mask, and make sure you educate others to get vaccinated. And guys, stay fit, and I'm going to see you again next time. This was Shreyas here, your physics master teacher, and I was going live from Bangalore. Hasta la vista. Take care.